Hi everybody. Just thought I'd give you a brief rundown on XML and how you can use it inside of a Java program. XML is an extensible markup language. You can create variants on XML which are customized for your own applications. You can give them a name. Probably all the alphabetic letters are used: AML, BML, CML. Anybody who could come up with a good name for a markup language has used one of the letters, and so now if you want to make up your own, you have to make up a rather more complicated abbreviation. Here's a sample XML I created out of nothing in particular, and it starts with a tag and ends with a tag, and the start tag has the angle brackets around it, and the corresponding end tag looks just like the start tag with a difference, and the difference is there's a slash. And these things are always supposed to be paired. So here's a start books tag, and now here's one book with a title, and here's another book with a title. And you can reformat these things so that they take one line or multiple lines. Maybe the Java for Morons books will become the next big thing, sort of like Java for Idiots. So how do you specify a correct XML? And the answer is you don't have to. It's a trick question. The parser will work with bad XML, but if you do have a specification, the parser will detect errors in the spec. Normally, you'd use a in the old days, you used to use a data type definition document, or a DTD, but those were not written in XML. Now we have an XML-based system called the XML schema, and that is XML for defining XML, and that tells us what tags are appropriate and when they're appropriate. So document type definition languages typically start with some sort of encoding, and the encoding that's normal is an ISO standard text type encoding called 8859, and you can make these standalone documents, and then you can define some of the doc elements. So here's a doc type element called a cart. That could be a shopping cart, and it has some product with a name and a price and some other stuff in it. And then you can define what a product is, and that's just some text, and we call that text PC data. The name and price, also PC data text elements. And then you can define a series of different carts with products in them. So here's an example of a cart. Somebody has purchased image processing in Java, and the price is known as $45, and there may be more stuff that follows. You can build an XML reader for reading XML, and there are parsers already pre-built for that, which will help you. But you can also build an XML reader for reading HTML, provided the HTML is well formed. So here's a way in which you can automatically generate XML using a serializable object, that is any instance of any class that implements serializable. And what you do is you run it through the so-called XMLEncoder. You create an output which can go to perhaps a file output stream, and then you write the object to the file output stream, and XML comes out. And this is XML which you can decode with an XML decoder and reconstruct an instance of the object. So the XML decoder, which will return an instance of the object that you've encoded, simply chooses a source for the binary information, which is in the XML file. In fact, it's human readable. It's text information, but you can treat it as binary. Comes in, decodes it, it'll do a read object, and it'll return an instance of an object. The question of what the actual type is of that object remains open. If you wrote out customer records, then what you'll read back could successfully be cast to the customer record type. So I created this helper class called XMLUtils, and what it does is it has a mechanism for taking an instance of an object and converting it to a string consisting of XML. Now, since XML wants an output stream, what I do is I fool the XML encoder into writing to a byte array output stream. And then once I flush the XML encoder, all of the information is in the byte array output stream, and all I have to do is convert it back to a string And that enables me to get, and this works reasonably well for modestly sized objects. It'll enable me to get a string representation of the object. So preferences are new since JDK 1.4, and they enable you to use a key to store values in a operating system managed preferences file, and that is as secure as the user ID and password for that operating system. And what you can do is you can take instances of objects, you can turn them into byte arrays or string arrays, then you can stream them into your preferences so that you can obtain a persistence which is unique to your user ID and login. That is, it's based in preferences. So putting out bytes is a perfectly reasonable way to serialize your objects. You can put them out as XML, or you can use an object output stream, or you could use an XML encoder. You can compress your objects. You could store all kinds of things, images, multimedia, audio. For storing XML, it's perfectly reasonable as long as it's modestly sized. Very large XML objects will not write successfully. So to store a string, just call put on the preferences and give it a key and a value. And then if you want to get back your string, just call get, and you can give it a default, and the default value will come in if it can't find the element associated with the key. And I can get the user preferences by going to the user root. That'll be the preferences that are associated with the individual who logged in, their credentials, in other words. I can also get preferences for the system root. That's more for the operating system, and that is a system-wide preferences. So if I want to get my user data, I go to the user root, get the preferences, and now here comes a key called com.docjava.foo, and the default is null, and I can return these preferences to whoever's calling them. It comes in as a string, and then I can decode them in any way I like. I can write user data in much the same way, get the user root preferences, use the same key, has to be identical, take the string that you want to save, and just call put. And there's a nice example in Feudal's preferences examples. And here we have a case where there's a rather complex dialog box with some very specific text. All of this gets retained at runtime because it's being serialized from a so-called web start bean, which contains all of these variables, and then that gets put into the preferences and then retrieved and used to repopulate the dialog box. It's called the web start bean. And so the web start dialog box is in the security package. I use preferences. I serialize out to an XML version of the web start dialog, and the next time you start, the old values are retained, which is very convenient because you don't want to type all those values in again. So you can quit and restart, and things like user ID and password and stuff like this, it's all retained because it's secure inside of the user's preferences. So if we wanted to give it a go, we should be able to find a way to do an inspection of the web start bean. And here it is. Web start bean has a number of interesting properties, and it implements serializable. And if we run the web start bean, we should be able to see some XML coming out, being stored into preferences. Moreover, we can see where the web start bean is being used. It's in the run web start bean. Let's see now, run bean panel. And if we open that up and give it a run, we should be able to see something. Let's see. Yep, there it is. So all of this has been restored from the serialized version, including passwords and remote system passwords, user IDs, all the things that are in the key store. This is stuff you need to keep secure. And you can also see it's very nicely put a border around the panel, and it's labeled the border with the name of the class. And that was all done automatically. In fact, the entire GUI was constructed automatically using introspection, reflection. So here we get the web start bean from the preferences, and then we pass it in without any additional construction effort into the run bean panel. And the run bean panel will take an arbitrary instance of a bean, and it will convert it into a graphic user interface. That's very convenient. So here comes the run bean panel, and you can see that he's using the so-called paragraph layout. And paragraph layout is one of those layouts that enables you to write arbitrary components on a single line, and then when you hit new paragraph, it starts a new line. Paragraph layout. We can do a quick demo of paragraph layout. Here you go. So that neatly organizes some data for you. It's a layout manager which is customized. You don't find this normally. Run bean panel also is unique to my toolkit. Its usage here is pretty straightforward. You just make a closable J frame, then you make up your dialog, and when you're done, you add the dialog to your frame. The pack will do the layout for you, and set visible will just make it show on the screen. The business about catching the exceptions, that all comes from the web start bean, because there are a number of different interesting things that it does with certificates and signing. The OK button, which appears at the bottom of the web start of the bean panel, is always present, and it will control when data is submitted. You hit apply, and then all of this data gets saved out to the bean, and a value is then returned, and the value will be the value of the web start bean as you've modified it. It automatically invokes the setters, automatically invokes the getters, automatically constructs a run bean panels, so to speak, with a border that's been titled by the class name. So in effect, it's a completely automatic mechanism for generating a graphic user interface for an arbitrary object. And that's how you use XML embedded in a system and automatic construction of graphic user interfaces with reflection. Thank you very much.